just to save time. Okay, everyone? So most probably we're going to have the two quizzes in one session. Okay, so chapter 8, multidimensional arrays. Okay, so there is no new concept in this chapter. Really, nothing. It's just that what we have seen in chapter 7, we are going to generalize it to any type of array. We're talking about multidimensional arrays as in arrays that have other arrays as elements. Like, so something like this, look at this. Thus far you have used one-dimensional arrays to model linear collections of elements. You can use a two-dimensional array to represent what we call a matrix or a table. For example, the following table that describes the distances between the cities can be represented using a two-dimensional array. It's basically an array that has multiple arrays. Each of these arrays will have the distances as an element. Yeah? So this is the first array, this is the second array, this is the third array, the fourth array, fifth, etc. And all of them are in another array. So it's a two-dimensional array. Type. And here we go. This is a very simple example. Again, we always start with the type, always. Then, how many sets of brackets do we have here? 2, meaning this is a two-dimensional array. If I want to create a three-dimensional array, how many sets of brackets? 3. Four-dimensional array, 4, etc. etc. Type. Of course, you give it a name, assignment operator. Now here, we already know the values, so we create the array straight away. Okay? Alright, so here we go. See? This is an array that has 1, 2, 3, 4, 5, 6, 7 arrays. Quickly, where do I go?
That's the back.
Yep, 1 minute. That has 1, 2, 3, 4, 5, 6, 7 arrays inside of it. Okay? Type. Since we have a two-dimensional array, this means how many indexes do we have really to access an individual element? Don't you remember that from Python? Yeah, Tuha? We use 2 indexes, sir, to access an individual element. Type yalla. What is the index of this one? I just put between brackets 2.
1, 2, 0,
0, 2. Very good. Index always starts from 0. So distances at index 0 is all the entire array, is all of this array, the first one. At index 2, 0, 1, 2 is this element, is this number basically. Type. We will talk about this in detail in a second. Here we go. How can I declare a two-dimensional array? You put the type, 2 sets of brackets, then you give it a name. How can you create it? You put the name, assignment operator, new, the keyword new, just like we did in chapter 7. You put the type again, and then again the 2 sets of brackets, and then you specify the size. You specify the size. Meaning this array has how many arrays, and inside each array there are how many elements. Here we go. There we go. Okay? Do the sizes need to be the same? No, of course not. Of course not. This is just a simple example. Here, in this array, how many, what is the size? I have 1, 2, 3, 4, 5, 6, 7. Alright, so I have 7 by 1, 2, 3, 4, 5, 6. Okay, it's also 7. 7 by 7. Again, this is just a coincidence. But the sizes don't need to be the same. Can I combine declaration and creation in one statement? Yes, of course I can. Again, you put the type, 2 sets of brackets, name, assignment operator, new, type again, 2 sets of brackets, and in each set you specify the size. And each set you specify the size. Again, the size does not need to be the same. You can put the brackets here after the type or after the variable name. Which is preferred? The first one or the second one? Yeah? The first one. The first one. This is preferred. Okay? This is okay. There is no syntax error here, but this is preferred. This style is preferred. Fine. Here we go. This is an example. And two sets of brackets. Again, the type can be anything. It can be anything. Any of the primitive data types that we have seen, string, and then we can also use objects, inshallah later on. Type. So n, two sets of brackets, the name here is matrix, mu, and then the sizes. I have 10 arrays, and each of these arrays I have 10 elements. Type. Or, of course, you can use this style. You can put the brackets after the variable name. Again, this is preferred. Now, how can you change an individual element inside any of these arrays? You access it using the index. Matrix at 0, this means the first array. At 0 again, the first element in the first array. 3, okay, here you go. Now the first element of the first array is 3. You can also use, what are these? Loops, very good. In a one-dimensional array, how many loops did I need to process the array? One, sir? Only one. One is in a one-dimensional array. In a two-dimensional array, how many loops do I need? Two, very good. Nested loops, here we go. Nested loops. One to traverse each array, and the other one is to traverse the individual elements of each array. So something like this. For int I is 0, I is this, then, okay, let's talk about the length first before we go through this example. Type. Matrix.length is what? يعني, what is the value? 10. Matrix.length is how many arrays does the array matrix have? Type. Matrix at I, at 1 for example, dot length. What does that mean? Matrix at 1 means the second array, correct? Dot length means the length of the second array. Understand what's happening here? Yeah? Alright, so for int I is 0, I is less than matrix dot length, I plus plus. I now is 0, for int j is 0, j is less than matrix at I. Matrix at I, matrix at 0, the first array. Dot length, j plus plus. Alright, matrix at I at j. I is 0, j is 0. What are we doing here? We are populating the arrays with what? With what? Random numbers. Between what and what? 0 and? No. 999. Int values. Yeah? Between from 0 to 999. Very good. So matrix at 0, 0, a random number. J plus plus. Matrix at 0, 1. Matrix at 0, 2. Matrix at 0, 3, etc. Until we are done with this array. Then we go back. Now I is 1. I 1 0 1 1 1 2 1 3 etc. until we're done. I now is 2 2 0 2 1 2. There we go. We are traversing the elements, the individual elements of each array in this two-dimensional array. Here is just an example of declaring, just declaring an array without creating it first. Questions so far? Questions so far? Done. There we go. So this is just basically a visual representation, a visual illustration, so that we as human beings understand what a two-dimensional array means. Again, the book assumes that we don't know anything about arrays in general, or lists in general. Now, does the computer deal with it this way? No. No, the computer does not look at it as a table. Does the Java virtual machine deal with it this way? No. It's just easier for us as human beings to understand. But it doesn't matter if you just say, for example, put all of these here values in one line. Right? Doesn't matter. Don't need to write it this way as a table. Type. Here, for example, I have a two-dimensional array that has how many arrays? 1, 2, 3, 4, 5. 5 arrays. And each of these arrays, I have how many elements? 1, 2, 3, 4, 5 as well. That's why here it says matrix new in 5, 5. Here, how many? Okay, here what are you doing? Okay, we are changing. We are accessing one of the values. Matrix at 2, 1, at 2. So the second array, this is the first array, the second, third array, sorry. First array, second array, third array. This is matrix at 2. At 1, 0, 1. Here you go. This is the location that I'm trying to access, or the index that I'm trying to access. assign 7 to it. Here you go. You change that value to 7. If you already know the values from the get-go, meaning you can hard code the values, and you write the values inside your code. You can use this notation just like we did in chapter 7. So here we go. Int, brackets, 2 sets of brackets, array. There you go. This curly bracket to represent the array, and then each of these are the individual arrays inside of it. So here we go. Here, are the sizes the same? No, this is not a square 2-dimensional array. No, here I have 4 arrays, and in each of them I have only 3 elements. So 4 by 3. Okay? Type. What is matrix dot length? What is the value? 5. Very good. Matrix dot length is 5. Meaning how many arrays does matrix have? Type. What is matrix at 3 dot length? Matrix at 3 dot length. 5 again. How many elements does the array at index 3 have? 5. Type here. Array dot length is what? No, not 3. 4. Array dot length, how many arrays do I have? Just 4. Array at 1 dot length? 3. There you go. The second array, how many elements does the second array have? Okay? Done. Ronnie? What is it? How much time do you need?
1 minute.
Quick. Okay. Declaring, creating, and initializing use shorthand notations. We've already talked about this here and then also in this example. We talked about this in the previous chapter. You can do this if you already know the values from the get-go. So you can also use an array initializer. This is what we call an array initializer to declare, create, and initialize a 2-dimensional array. For example, something like this. This is the same as creating the array first, then accessing each element and giving it and assigning a value to it. Yes? ايش قاعدين تسووا انتم تبع؟ يا زلمة محمد. ايش قاعدين تسووا؟ تعال بدوني قدام. قدام شوف. بدوني هنا جنب مصطفى. يلا كويك. مين كمان هو مركز معنا؟ Here, next to Mustafa, yeah. Next to Mustafa, I said. Next to Mustafa. Okay. Alright, so length. Again, we've already talked about this. Yeah. X is what? A 2-dimensional array. Of which type? And it has how many arrays? 3. And each array has how many elements? 4. Very well, very well. And this is how we can access the index of each. So this is x dot length is 3, x at 0 dot length is 4, at 1 is 4, and at 2 is 4. طيب. Again, the same thing. Array dot length here is what? 1, 2, 3, 4. طيب, if I try to access something like an array at 4, does array at 4 exist? Does this index exist? What is the last things we have here? 3, 0, 1, 2, 3. That's it. If I try to access an index that does not exist, you will see this exception, array index out of bounds. Inshallah, we will learn how to deal with exceptions as well. It's very similar to Python, try catch instead of try accept. Okay. Ragged arrays. What do we mean by ragged arrays? Meaning, when we have a 2-dimensional array, do all of the arrays inside of it need to be of the same size? No. No. No, it's not a rule here. Yes, if you declare it this way, if you declare it and create it, yes, they need to be of uniform size. All of them have to be of the same size. But if you already know the values from the get-go, you can use an array initializer like this. Can you see it? And each of the arrays have a different size. So what is matrix.length? 5. I have 5 arrays here. 1, 2, 3, 4, 5. Type matrix at 1 dot length. 4, very good. At 1, this is the array, dot length, 1, 2, 3, 4. Matrix at 3, dot length. 0, 1, 2, 3, very good. 2, here we go. This is what we call a ragged array. So each row in a two-dimensional array is itself an array, so the rows can have different lengths. Such an array is known as a ragged array. Alright? But you cannot create it unless you already know the values from the get-go. Okay? Otherwise, if you're going to use this notation, then the size is going to be the same for all arrays. Like, yeah. So here we go. Processing two-dimensional arrays. We already have seen almost all of these examples about one-dimensional arrays. Now we are going to generalize them to include two-dimensional arrays. And then at the end of the chapter, we will say that we can do the same thing regardless of how many dimensions the array has. Type. Initializing arrays with input values. Okay, how can I populate the array with values from the user? I create my scanner object, I ask the user, enter matrix.length rows. Let's just say, for example, I create an array that is 4 by 3. So enter 4 rows and 3 columns. There we go. Yeah, for int row is 0, row is less than matrix.length, which is 4. Did I say 4 by 3 or 3 by 4? Good then. 4 by 3, okay, 4. For int column is 0, column is this than matrix at row dot length. All of them are the same length, so this is 3. Column plus plus. Matrix at row at column. 0, 0. Read the input from the user. 0, 1. Read the input from the user. 0, 2. Read the input from the user. 0, 3. Read the input from the user. Done. I said 4, huh? Done. Yeah. Next row. 1, 0. 1, 1. 1, 2. Okay? And this way you can populate all of the arrays. Every element inside each array using user's input. Questions here? Questions? Fine. Initializing arrays with random values, we've already seen this example. Yeah. In this example, I am populating the array with which values? اللي هم كم? What are the values? 0 till 99. Very good, very good. From 0 till 99. Okay. Printing, again, and you can do it in multiple ways. It depends. It can be super fancy, or it can be very basic. Again, for int row is 0, row is less than the length, row plus plus. For int column is 0, column is less than matrix at row dot length, column plus plus. System dot print. Here, I am printing every element of a certain array, and how many lines? Every element of a certain array, and how many lines? 1 line. With what in between? With spaces. After I'm done with that array, new line. Then move on to the next array. Yeah, access the next array. Print all of the elements of that array in 1 line with spaces in between. New line. Access the next array. Here we go. There we go. You can print all of them in 1 line. You can remove this and all of them are printed in 1 line. You can use printf and make things look fancy. Again, this depends on how you want to print the array. The arrays. Summing. Anything new here? No. What do we call this variable? No, it's not a count. Accumulating. Very good. It's not counting, it's accumulating. Very good. This is an accumulator. Yalla again. For int row is 0, row is this than matrix at length, row plus plus. For int column is 0, column is this than matrix at row dot length, column plus plus. Just add everything in total. So total plus assignment operator matrix at row at column. This will add all of the elements to total. Like what if I don't want to do it this way? What if I want to add all of the elements of each array separately? What is it? So, okay, so you don't need, It doesn't matter what you do with it yet. You want to print it, you want to tell the user, maybe you want to save it in another array to keep track of it, whatever it is that you need to do. But if I want to add the elements, let's just go back to this example here. Where is it? This one. If I want to add the elements of each array separately, how can I do that? What do I need to do before I move on to the next array? So I added the numbers of all of these arrays. What do I need to do before I move on here? Again, I'm calculating the total of each array separately. Do I just continue adding also these numbers? Very good. You need to reset. You need to reset the accumulator. Here we go. So here, in this example, where is it? Printing sum. All right. Here, all of them together. Right? Before you move on, so you can add it here, or here, or here. You can reset it here or here after you're done. It doesn't matter. Okay? To keep track of it, you can create another array before the loop and name it, for example, I don't know, total array, whatever. And then every time you calculate the total of a certain array, you add it to that array. This way you can keep track of the individual totals. Or you can just print it. If you don't want to keep it in an array, if you don't want to keep the totals in an array, you can just print it. If you don't want to keep track of them, you don't want to store them. Regardless of what you do with the total of each array, before you move on to the next array, so you can put it here. Before you move on to the next array, make sure to have total 0 again. Otherwise, it will add the totals together. صح ولا لا؟ هتجمع على بعض، هتجمع الجديد. طيب, there is a good example in a second, but it's not about summing each individual array. No, it's about adding or summing arrays by column, like this. And I don't want to sum the elements of each array, no. I want to sum the first element of all of the arrays. The second element of all of the arrays. Instead what's happening is I'm going here by column. How can I do that? Let's see. So this is printing. So here we go. Summing elements by column. Again, am I summing elements by array? No. I want to sum all of the first elements together, all of the second elements together, all of the third elements together. So how can I do that? Yeah. For int, column is 0. Column is less than matrix add 0.length. Now, if you can notice here in this kind of loop, which index gets fixed? The row. Row is 0, column is 0, so it says 0, 1, 0, 0, 0, 0, 1, 0, 2, 0, see? 0 is fixed until you are done. Then you move on to the next one. 1, 1, 0, 1, 1, 1. You see, 1 here is fixed. We want to do the other way around. We want to fix the second one. واحنا ماشيين by column, we want to fix the second one. So we want it to be 0, 0, 1, 0, 2, 0, like that. So we want to fix the second index, not the first one. Now, how can we do that? For int column is 0, column is less than, matrix add 0.length. The length of the first array. All of them have the same size, so it doesn't matter which one you choose. Matrix add 0.length. Column plus plus. Yeah, make sure, here we go. See, the total here is being reset every time. Type. For int, row is 0, row is less than matrix.length. Total plus a sum operator at matrix at row at column. Now column here is 0, row is 0, 0, 0, row plus plus, 1, 0, row plus plus, 2, 0. You see here, the second one is fixed. After you're done with this column, print it. You can always store it in a separate array. If you don't want to print it, I mean. Type. Done. Yalla. Go now to the next column. Now column is 1. Okay. 0, 1. 1, 1. 2, 1. You see here? We fix the second index. And then after you are done, again, we are just printing them here, or you can just store them in a separate array. Questions? دايما كذا في المحاضرة ما عندنا أسئلة، تطلع التحافة بس في الاختبار. صح؟ لا مفهوم، لا كل واضح، كل واضح. في اختبار اللاب اوه كيف يعني؟ كيف نستد لوب؟ الله اكبر. يا ريت ما لهم ولا ريت لهم علاقة ببعض، ما لهم علاقة ببعض، واحد يسوي شغلة والثاني يسوي شغلة ثانية، اوه لا جدا صعب. هذا أصعب من اختبار اللاب. ليش ما عندكم أي سؤال؟ سبحان الله، شرح سحر، صح؟ Okay. So this is summing elements by column. طيب, random shuffling. Now this is very similar to the random shuffling example from the last chapter. Again, we just want to move the elements around. And if I go back to this example here, I just want to move them around without any clear pattern yet. So what do? Every time before I access a certain index, I generate a random index from the array. And then I swap them. Here you go, randomly. So here it is. Random shuffling, yeah, for int I is 0. I is less than matrix.length I plus plus. For j is 0. J is less than matrix at I dot length j plus plus. Again, we are just accessing the individual elements just like we are used to. Before you start swapping, you need to generate the index, the random index. We need two. Here we go. Int I1 is math.random times the length. So let's just say مثلا matrix is 3 by 4. 3 by 4. So matrix.length is 3. Right? Random times 3 is what? From 0 till 3. Excluding 3. Very good. 0 till 3, excluding 3. Change it to int. 0 till 2. Yeah, 0 or 1 or 2. The int values. Here we go. This is the first random index. Check, Muhammad. Check. What is it? You don't understand this? Fine. Type. Math.random times matrix at I. Now all of them have the same length. So what did I say? 3 by 4, صح? Okay. So 4. Yeah. Random times 4 is what? 0 to 4 without 4. Excluding 4, meaning from 0 to 3.999 type. Change it to an int. 0 or 1 or 2 or 3. Here we go. This is the second random index. Now swap them. Swap. So temp is matrix at I and j. Matrix at I and j. Change its value to matrix from I1 and J1, and then change the value of I1 to J1 to the previous value of matrix at I and J. We will go through the array this way for each individual index. Yes?
Why do we have to swap by the end?
Because it's random shuffling. That's the point of it. Yeah? So we generate random indexes and then we want just to move the elements around with no clear pattern. There is no clear pattern for it. Passing two-dimensional arrays to methods. Again, nothing is really new here. Let's look at the example. Here it is. Okay. Yeah, I imported scanner. My class is passed two-dimensional array. In my main method, what did I do? Okay, let's look at the methods that I have. I have get array here. What does it do? It returns what? Huh? What type of an array? Two-dimensional int array. Very good. So a get array returns a two-dimensional int array, and then I also have sum. Sum returns an int value and receives a two-dimensional int array. Okay? طيب yeah. In the main method, I declared the two-dimensional int array, and then I called get array. I go to get array. Get array starts executing. Yeah. Create the scanner here, and then ask the user. Oh, here we go. create an array. Here we go, int 2-dimensional, the name is m, new int, okay, I didn't even ask the user how many. But no problem. If you already know the values, no issues. So this is a simple example. Alright, enter m.3, 3, m.length, 3 rows, and m at 0.length, which is 4, and 4 columns. Then I go through the array, and then I take the input from the user. So here I'm just creating an array and populating it with input values. Return m. Return who? Which is? Which is what? M is column? The array itself, after populating it with input values, return it here. So the array comes back here, and now here we go, it is assigned to this array. Yeah. System.out.println, sum of all elements is, and then call the method sum and pass the array to it. Yeah, here you go, this is sum. Sum receives the array here. Yeah, and total is 0. Again, yeah, go through the array. Int row is 0, row is less than m.length, row plus plus, and column is 0, column is less than m at row.length, column plus plus, and add everything together in total. At the end, after you are done, return total. So total comes back here, and then it is printed. Questions? Anything new here? Nothing is really new. Exactly like we did with single-dimensional arrays. Okay. طيب. Now, since we already know about two-dimensional arrays, or about arrays in general, now you have the skills. Now, come back 3 minutes. Quickly. Leave your phone here. Stop. Okay. Now, since we learned about all of these skills, about all of these, since we learned so much about arrays, we can create some really fun, or we can solve some really fun problems. Like this one, for example, grading a multiple choice test. You can do that now. What's a multiple choice test? It's basically a table. How can you go through it? You can just create a two-dimensional array and go through it and check if the answer is correct or not. You can, okay, make sure to study all of these problems, not just because they are long and we cannot cover them in class, we just forget about them. No. Make sure to study these problems. Grading multiple choice test. Even this, look at this. Finding 2 points nearest to each other. 2 points. Each point has how many sets of coordinates? 2. Right? 2 coordinates. 2 coordinates. That's why using a two-dimensional array makes sense here. Type. What else? What is this? What is this game? Sudoku, yeah? Do you know this game? You all know this game? Here you go. Now you can actually create something very similar. Yes, it's not going to be as fancy as the GUI interface, but inshallah later on you will learn how to create a graphical user interface. But the most important part, the most important thing here is to learn the algorithm first. How can we actually create a Sudoku game? Then you can link it to an actual interface later on, no problem. Right. So make sure to study all of these examples. Now, after we've seen two-dimensional arrays, can we just generalize everything we have seen to a multi-dimensional array? Yes. Everything that we have seen that with two-dimensional arrays, we can also apply with multi-dimensional arrays. So occasionally, you will need to represent n-dimensional data structures. In Java, you can create n-dimensional arrays for any integer n. The way to declare two-dimensional array variables and create two-dimensional arrays can be generalized to declare n-dimensional array variables and create n-dimensional arrays for n that is greater than or equal to 3. And this is an example. Look at this. I have scores. Scores is what? Scores is an array that has 1, 2, 3, 4, 5, 6. 6 arrays. And each of these arrays, I have 1, 2, 3, 4, 5. 5 arrays. Array that has 6 arrays And each of these arrays, I have 5 arrays. And each of these 5 arrays has how many elements? 2. 2. So what does this represent? It represents the scores of students, yeah, in 2 different exams. Understand what's happening here? The scores of how many students? 1, 2, 3, 4, 5, 6. 6 students, okay? And how many exams? 1, 2, 3, 4, 5. And 5 exams. And the exam has 2 parts. Here you go. Here you go. Or you can think of it as, it can represent the scores of 1, 2, 3, 4, 5, 6. 6 classes. 6 classes. Inside each of these classes, I have 1, 2, 3, 4, 5. 5 students. And each student has the grades of 2 exams. Okay? So you can think of it, yani, it depends on the problem that you are solving. Here, yeah. Scores at which student, which exam, and which part of the exam. This is the problem in your book. Type. Since it's a 3-dimensional array, how many index do I need to access an individual element? 3. 3. Type. What is the index of this number here? 2, 2, 1. Excellent, excellent. It's in the 1, 2, 0, 1, 2. It's at index 2. The array at index 2. The array at index 2, which array inside it? 0, 1, 2 again. So 2, 2. Which one of these? 0 or 1? 1. So 2, 2, 1. Here we go. Now what is scores dot length?
So,
10. Scores dot length. 1, 2, 3, 4, 5, 6. What is scores at 3 dot length? 0, 1, 2, 3. This is at index 3. 1, 2, 3, 4, 5. What is scores at 3 at 1 dot length? 2. Scores at 3, 0, 1, 2, 3. At 1, 0, 1. Dot length 2. Okay? Type. Again, this is calculating, this is a simple example by the way. Calculating the total scores. Write a program that calculates the total score for students in a class. Suppose the scores are stored in a 3-dimensional array. The first index refers to a student, this one. This is the same example. The second refers to the exam, and then the third to the part of the exam. It tells you how to calculate it, but you need to calculate. Your program displays the total score for each student. For each student. Yeah, and for each student, I'm going to add the elements of each array, meaning the elements of these individual arrays together. Here we go. The first row, then all of the second row, then all of the third row. Okay? Make sure to study this example carefully. What is it? See back? Yeah, quick. But you need to be quick. Alright, the same goes with weather information. Suppose a meteorology station records the temperature and humidity at each hour of every day, stores the data for the past 10 days in a text file. Inshallah, we will learn about how to read from text files. Now, this example is not about reading from text files. It's just about how we can represent the data in a 3-dimensional array. Each line of the file consists of 4 numbers. So here we go. So I have 4 numbers in 10 lines. Day, hour, temperature, and humidity. Write a program that calculates the average daily temperature and humidity for the 10 days. Again, make sure to study this example carefully. Guessing birthday. Remember the example where we show the user sets? Remember them? And then we ask the user, is your birthday, the day itself, is it included in this set? Yeah? If the user says yes, we take the first number of the set, then we add all of the first numbers together. Remember that? what did we do to represent the sets? We created strings. Remember it? We actually hard coded. It was a string, and that's how we showed the use of the sets. Here, we can simplify the guess birthday example. So guess birthday gives a program that guesses a birthday. The program can be simplified by storing the numbers in 5 sets in a 3-dimensional array. You can store them all in a 3-dimensional array and then add the first number of each dimension, of each set I mean, if the user says yes or no. Yani this can be very, because it was a long code unnecessary. Now using arrays, we can write the code in like 5 lines or something. So make sure to look at this as well. Any questions about chapter 8? Any questions about chapter 8? طيب صحصح شوي. Let's take a 2-minute, exactly 2-minute break inside the class, and then we will start with object-oriented design.